The example asks us to differentiate different functions here. Um, the first one is sums of two functions. So if you're trying to find the derivative, this will be derivative of first one minus the derivative of second one. And then for this one, we use the constant multiple rule, 3 to the power x prime minus. This is product rule. So derivative of cosine x, x cubed, plus cosine x, the first one itself, times the derivative of second. E to the power x, the derivative is e to the power x minus. Derivative of cosine x is minus sine x. That's another basic differentiation rules that you learn in week 4. And here, this is cosine x. Derivative of x to the power 3 is 3x squared. You can simplify, multiply signs inside and outside, and everything will work nicely there. And that's the derivative. For the second one, I have quotient. So I need to do f prime x is derivative of numerator times a denominator minus derivative of a denominator times the numerator. And then the denominator squared. Well, let's just go find the derivatives that we are given there. So derivative of e to the power x minus e minus 1. This will be derivatives of each piece and then subtract them, yes? This will be derivative of first one minus derivative of e minus derivative of x. And from here, we get e to the power x. What is derivative of e? Don't confuse e with function e to the power x. E is just a constant. It doesn't have any x in it. It means that when we're differentiating, we have to apply the constant rule, which will be 0. And derivative of x is just 1. So this is e to the power x minus 1. I'll write it up there. Times e to the power x plus e to the power minus x. Plus then e to the power x minus e minus x times. Okay, so I'm doing derivative of e to the power x plus e to the power minus x. Well, here, this will be derivative of e to the power x plus derivative of e to the power minus x. You know what is derivative of e to the power x? How about derivative of e to the power minus x? Well, here you can do two things. One is that you write e to the power negative x as 1 over e to the power x. Then you have quotient of two things. And what you can do now is that apply the quotient rule. So it will be derivative of 1 times e to the power x minus 1 times derivative of e to the power x over e to the power x squared. Derivative of 1 is 0. So this first piece will go 0. And derivative of e to the power x is e to the power x itself. So here I will get, oh, this is coming from here. Now for the second piece, you get minus e to the power x, e to the power x squared. And then cancel that with that. You see that you get e to the power x minus e to the 1 over e to the power x, which is same thing as e to the power x minus, I can bring it up and switch the sign of the numerator, the power exponent. So it means that here I have e to the power x minus e to the power minus x over the whole thing, which is this guy squared. You may ask yourself that what would be the second method to differentiate this guy? That is something we can do right at the end of this session using, you can also use the chain rule. And that's one of the things that you will notice, how chain rule can help you to do more easier differentiation. Okay, let me finish the third one and then I will ask the questions. Okay? So for this one, again, the sums of two things, we can differentiate the first one and difference of two things. That's basically the same thing as so difference of the derivatives. Then the first piece is product of two things. So we differentiate first one times second one plus first one times derivative of the second minus 3 comes out, and then derivative of tan inverse of x. Here now, derivative of x is 1. So this will give me tan x plus x times derivative of tan x is secant squared x. Oh, there's a prime there. Minus 3. The derivative of tan inverse x is something that you learn at the end of week 4, and as you know, it is going to be 1 plus 1 over 1 plus x squared. And that is the derivative of the third function that we were looking